this video, we're going to look more at Lab 4, and in particular, we're going to be looking at the simple linear regression portion that is in SAS. And just like in the R video, I'm going to work through the pieces of the SAS code that are given to you, but I won't be working through the part that has you write your own code. Alright, so just as with R, whenever we work in SAS and you're creating a script that has the code in it, you always want to start out with some comments. And these comments are just to remind you what it is you're doing in this particular script. So I'm going to fill in these different pieces. Today is the 31st. And so now if I open up this script later on, I'm going to remember what it was for. The other thing that I want to make sure to do is to go ahead and save this script. So I'm going to go up here to File, go to Save As, and then you can navigate to where you want to save this file on your computer so that you'll have it to turn in. And now I'm going to cancel because I don't actually need to save this file for my purposes, but you will want to make sure that you do that. Alright, so the next thing we're going to do is we're going to read the data into SAS, and then we're going to do some data checks. So I'm going to copy in this code from the lab. And you'll notice here is what the code looks like. So the one thing that you're going to need to change is this piece right here. And so this is going to be the file path where you have the file stored. So on my computer, if I go through my File Explorer, this is where I have the delinquency data set stored. So what I can do is a kind of a quick way to find that file path is I can click up here and I can copy, and then I can come down here and just replace. Now do make sure that you have both the file path as well as the file name at the end. You want to make sure that you have both of those. Now you'll notice as part of this code we have out is equal to, and then we have work dot, and then the name of the data set. Just a little bit about SAS. SAS uses also some internal ways that it stores data sets once they're read into SAS. The default place, these are called libraries, where SAS stores those is the work library. So this is why you will typically see work a dot in the front, so you're not going to want to change that piece. That is just telling SAS when you read in the delinquency data set, I want you to save this to the work library. Everything that follows after the period, that is what you want to name the data set. So we're going to name this one delinquency data. Right? So we can run this by highlighting the code and click our little running man. So you always want to check up here to make sure that there's not any red. If you don't see any red, then you know everything was read in properly. If you do find something, you do find some red up here, the most common error is that that file is not in the location that you specified. So if you get an error, the very first thing you want to do is make sure that that file is in the location that you gave here. Then we can do some quick data checks. The easiest way to do that is to use a proc print statement to print the data and just to look at it to make sure everything looks okay. Alright, so next thing we're going to do is we are going to create a scatter plot and fit the model. So again, that code is given in the lab assignment. This first piece is what creates the scatter plot. We're going to use proc sgplot. And within here, just some different pieces. Here is where we tell SAS what data set we want to use. Here is where we tell we want IQ to be the X variable and DI to be the Y variable. You can change this to give your plot a title. And this is where we change the labels. So the label DI, remember that this was the name of the variable in the data set, and we're saying we want it to have the label delinquency index. We want the IQ variable just to have the label IQ. So if we run this, here's our nice scatter plot. We can see those labels are there as well as the title. And then to get the regression information, we're going to use the proc reg. Now, one thing that to notice here is that SAS does not care if things are capitalized or not, where R does care. So that's why here I've got lowercase and here I've got uppercase, just to illustrate that it doesn't matter for the purposes of SAS. So running this, Here we have all of the output. So SAS actually gives you a lot of output when it fits the regression model. So here are our output statistics. We've got our IQ. This is actually delinquency index, which is the dependent variable, as well as residuals and other pieces of information. We'll cover some of these more later. Further up, this is where you actually get your output that you've seen. So notice here you've got your estimate of the, oops, sorry, I'm in the wrong spot. Here you have your estimate of the intercept, and here you have your estimate of the slope. So all that information is given there. You also have all of your diagnostic plots, as well as the plane scatter plot, and as well as the scatter plot with the regression line. And then these are what we call some confidence limits. We'll talk more about those later on. One thing to notice, if you wanted to copy and paste these into a different file, like in a report or something like that, you can right click and save picture as to save any of these individually. Now, one thing to notice here in the procreg statement, I have included this IDIQ. You don't have to include this, and often I will take it out. So I'm going to take it out here. Notice if we run this again, the code will just run fine, and you will notice here are your parameter estimates, as well as up here from when we ran it the first time and it didn't change anything. I have the ID in there to begin with just to show you that that is an option. So if you were running some code and you had a separate variable that you were using to ID your different observations, that's where you can add that in. But in this particular case where we just have DI and IQ, it's not actually needed. And for some of the other examples that you look through, you probably won't need it either. Again, I just wanted you to see that it was in there. All right, so next, what we can do is to find the confidence interval for the slope. If we go back to our results, notice that that is actually already given as part of the output. So that's right here. And if you go back and check the R code, that is the exact same values. Now to find R and R squared is provided as part of the procreg from step 3. So if we look in here, here is your R squared value, and that should match the R. If you wanted to get the correlation, which is just R by itself, you could either take the square root of this value, and then remember that if you do take the square root to figure out the sign, you have to look at the sign of the slope, so it would be negative square root of R squared. Or there's some code in the lab that you can use. And here's what that code would be. And so looking here, here is the output from that correlation procedure. And how the correlation is presented is it is presented in this table right here. So the correlation with DI in itself is 1, and the correlation between IQ in itself is 1. So really the piece that we're interested in is DI and IQ together, and here you have that value. You will notice that there is a value underneath here that is the corresponding p-value, and you can see that comes from up here at the table if we were to do a hypothesis test to see if this value was non-zero. So in your previous courses, if you looked at the hypothesis test for the correlation, this is where that p-value would be. All right, to get prediction and confidence intervals, that code is also in the lab, so I'm going to go ahead and copy it, go back to where I'm keeping all of my code in my script. Similar to R, to get your prediction intervals, you will need to create kind of a temporary data set or create a new data set that holds that new value that you're interested in. So here is where I'm going to create that data set. I'm going to call that data predict data, and I'm going to input 2 variables, IQ and DI. Cards, this line you're not going to want to change. Cards is what lets SAS knows it's going to get some new data lines. And then you'll notice here in the actual data set, what I'm doing is I'm setting IQ equal to 15. And then where DI would be after that, I have a period. In SAS, the period is a missing value. So what this is essentially saying is I want to know what happens when IQ is equal to 15 and DI is missing. So we create that predict data data set. And then what we're going to do is add this data set onto our original one. This is the code that does that. So notice in this code, it's saying the base data set is the delinquency data, the original one we worked with, and what we're going to add on to the end is the predict data. So now if we reprint our delinquency data that we had earlier, notice here is our original data set, but we now have a new observation at the bottom where IQ is 15 and DI is missing. And then we just rerun our regression model. And again, we are going to get all of that output again, but remember when we had these output statistics, notice there is a new one down here at the bottom with many of the values missing, and that's because we were saying we didn't know what the value of DI would be. So it gives us a predicted value, and we also get the prediction interval and the confidence interval. And so both of those are given here. And then the last piece are those diagnostic plots. And remember that the diagnostic plots are part of that output from the regression. So one of the nice things about SAS is that when you run the proc-reg procedure, you get most of the information that you need for linear regression. The downside is you get so much information that you really have to narrow it down to what it is that you are looking for. Often when we're writing reports or we're giving information, we never just want to copy and paste all of that output to give somebody. We want to be selective about what those pieces are and make sure that we pull out just the pieces we need and we explain those pieces well. All right, so that is going to conclude this portion of Lab 4.